they don't like bright light. So I'll just pop them out. There we are. Move that to there. And there are the specimens I'm going to put onto the microscope for you. And I should point out, before anyone worries, what I'm going to be showing you was collected from my garden, just out there through the curtain, just this morning. And as soon as I'm finished, I'm going to be popping everything back into the garden where I found it. So all these little creatures and things are going to go back. So let's begin with these. I'm going to put them under the microscope here. And then I will see if we can see what we want to see. Right, so I have to focus the microscope, and then I'm going to turn the camera on the microscope like that. Boom, there you go, look at that. Cool. Now, these are, of course, I'm sure you know what they are. You could tell me in the chat if you knew what they are. I'm just going to talk a little bit because I can see the chat window. And hopefully, if you put something in the chat, I will be able to, if I do that, I can see all the chat. Yeah, indeed, yes. And it's all coming up. It's too quick. Unfortunately, I haven't got my glasses on, so I can't actually see what it says very well. Exactly, Alison and is it Deanne and Walden and Angela? Yeah, all of you, you get it. Woodlice. Obviously, these, of course, these are woodlice. And when you look at them up close, you can see a little bit more detail. And the first thing I love about this is, and I'm going to just jump to this. The first thing I love about this is look at the beautiful colours on the backs of the woodlouse, especially this big one here. Okay, this big one here, which I sort of zoom around like that. That one is the oldest one, and you can see it's got these lovely yellow speckledy bits on the back. And actually, what it's doing there is it's storing calcium, which is an element which is important for you, you're up there, for bones and stuff like that. But these guys store the calcium just underneath their shell because it's what makes the shells of the insect. It's important in the shell, so they store a little bit, which is why you get these white flecks. There's 3 of them there. They are definitely alive. I have a little pokey stick. I shall give them a poke just to prove that they are alive. Come on. They're sort of looking a bit dead, aren't they? They basically don't like the bright light. Yep. They're just about, I think they're sort of sitting there. They're a bit grumpy. I might just put a spot of water in there for them, actually. I fear they might be getting a little bit dried out. It's a little bit of water for them. There you go. That's better, isn't it? Yes, they don't like it very dry. Now, the interesting thing about woodlice, and one of the reasons why you need a magnifying glass, or at least a microscope when you look at woodlice, is that woodlice, there are actually about 50 different types of woodlice in this country alone. Now, I know down in Suffolk, and I know some of you might be down in there, and that's where the headquarters for STEMtastic are. They have a type of woodlouse. Oh, look, you see that one's decided, he's like, oh, I'm getting all wet, I'm going to move now. They have, you get lots of pill bugs, the ones that roll up into little balls. These are what are known as common rough woodlice. I have to get it right. And the only way you can tell them apart from other woodlice is by looking at the end of what is known as the ocellus. Now, the ocellus is a part of their body which is right down here at the end of this sort of wiggly bit here, right? The flagellum. And if the ocellus has 3 segments, they're the common rough. And if it has 2, they're the common shiny. So shall we zoom in on the end of their flagellum here? If I zoom right in like this, I have to focus again a little bit. There, can you see? They're being very well behaved. And it's got 3 sections. There's 1 section, 2 sections, 3 sections. And that's the only way you can really tell the 2 different types of creatures apart. They're completely different creatures. You can also see here, look, these are its eyes here. They kind of look like blackberries. If I turn the brightness up like that, they kind of look like little blackberries, just one there and one there. On this one at least, and those are its eyes, little compound eyes. Okay, right, let's do a little straw poll. The next thing we're going to look at, I've got some other things we can look at, and we've got a choice. You can either look at something gross and disgusting, or you can look at something scary. Let me know in the chat, and I shall take a random straw poll whether you want gross or scary. And in the meantime, I'm going to put these little fellas away. Gross, scary, 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 gross, gross, scary, gross, 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 scary, 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 gross, slug, scary, 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 gross, 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 scary, scary, scary. Well, it seems to be pretty evenly distributed. Oh, we should have put one of those polls up. I should have got you to do it. I reckon scary is actually coming up more than gross. So, okay, let's do scary then. Here we go. This is for the people who wanted the scary. Now I'm going to go back to me here like this so that I can get this in place. And then we shall switch to it. Okay, are you ready for the scariness? And actually, I've got to turn the brightness right down for this because this does not like it bright. Are you ready? Here we go. Here's the scary. Oh, yes, a spider in your... Oh, it's gone. Although I say it, he, it's actually, this one's a she. This spider, this is a spider called Tenegaria Domestica. It's the common house spider. And don't worry, it's not going to get away. It's underneath a cover. Now, I know some people do get scared of spiders, but this one is tiny. This one is less than a centimetre long. So it's a really tiny one. And when you look at them in a bit of detail, they are really quite beautiful creatures. And the thing I wanted you to do, though, is... it's gone. I was going to ask you to count the legs with me. Here we go. Let's see if we can get it to stay still. Right, let's count the legs quickly before it moves. 1, 2. Actually, I have a way of doing this. What I need to do is I'll just get it still for a moment, and then I have a freeze frame button. Boom. Right, I've frozen the frame. So let's count the legs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, well, hang on. That can't be right, can it? Let's do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It definitely has 10 legs. This is an ordinary spider. In fact, this is the commonest spider you're likely to see. This is a common house spider. This is the sort of spider that you find all over the place. These aren't the really giant spiders. They're not that big, but the really giant spiders that you find like that in the autumn, those are a different type of spider. Those are Tenegaria gigantea. Whereas this Tenegaria domestica, it is still alive. It's climbing around in the little pot here. This is a freeze frame of it. So it's quite handy. I can do that. But the spiders have, yeah, exactly. Why are there 10? Somebody's saying, who's that saying? Gemma and Patrick saying, why are there 10? How can there be 10? Yes, exactly. And this is the beauty of looking at things with a magnifying glass or a microscope. Suddenly you realize that there's more to it than you thought. Yes, spiders have 8 legs. They also have 2 arms. So they have 10 limbs in total. I have 4 limbs, 2 arms, which you can see, and 2 legs, which you can't because they're below the camera. But trust me, I have 2 legs. So I have 4 limbs. Spiders have 10 limbs, 8 legs, and 2 arms. The arms aren't called arms, though. They're called pedipalps. And the pedipalps are there to help them maneuver their prey around. So when they catch something, they run over to it. This thing makes a sort of a wispy web, excuse me, a wispy web. And then when it wants to catch something that lands in its web, it'll run over, it will grab it, it will bite it, it will inject poison, and then it will wrap it up in silk, in spider web. Okay. And to maneuver the prey, the thing that it's caught that it's going to eat later, it can't use its hands, its arms rather, because they're too big. So what it uses instead is its pedipalps, which are right here next to its face, okay, like that. And it uses these, they're kind of like Tyrannosaurus Rex arms. They're kind of a bit short and useless unless something's right here next to its mouth. So there you go. So this spider is actually, she's actually, if I go back to the live picture, she's actually quite distracted. She doesn't like the bright light here. They basically don't like the bright light, although you can see just there, you don't, oh, she's gone again. You don't often get to see a lot of detail on the spider. And I'm going to race on because there is so much I could show you on the spider alone, but I know that a lot of people don't like spiders. So let's go to something gross. I said you had, oh, somebody's asking me, how do I know it's a girl spider? I know it's a girl spider because of the shape of its abdomen here. Okay, this bit here, I know it's a girl spider because that bit there is bigger than it would be if it was a boy spider. The boy spiders have much narrower back ends, so to speak. Their bottoms are very thin, whereas the female spiders, because they've got all the egg-laying stuff inside their abdomens, needs to have a bigger abdomen. So that's how you can tell for this species. That's not true for all species. Right, put that back under my little metal tray. Actually, what I'm going to do is, now that we've seen that spider, I'll put the spider right over there and the woodlice right over there, and then we'll cover them up so that they don't get any shiny light. Because now what I wanted to show you is, I was going to show you something gross. Let's get the gross thing in the picture. Right, here we go. Right. Here is something really rather gross. Oh, I'll take the lid off this as well. And disgusting. This, ladies and gentlemen, boys and girls, Georgia is saying, will she die after she lays her eggs? No, these spiders, this spider will live for, I've got one in my garage that I know that I've been had there for years, and it's about 5 years old. The spiders will live for 5, 6, 7, 8 years, those spiders. They can grow to a reasonable size. So is it a flea? No, it's not a flea, but you're not far wrong. This is Pediculus humanis capitis. That's the Latin name. We use Latin in a lot of science when we're talking about animals, because that means that nobody understands what the scientists are talking about. No, what that means is that it doesn't matter where you are in the world. If I say Pediculus humanis capitis, you would know immediately what this was. This is a head louse. This is a head louse from me. Oh yes, this is one of my head lice. Now, I should point out that I am completely clean at the moment. Exactly, ew, gross, disgusting. Yes, this is, well, it's sort of the same as a nit, somebody's saying. It's not a nit. I'll show you what a nit is, though. So yes, anyway, what happened was I've got a couple of kids. They are currently, everyone is banished from the kitchen. We had to have breakfast really quickly so that everyone could be thrown out because it's Saturday morning. So my kids are teenagers now. They're upstairs, probably watching YouTube and sitting on their beds. But before, when they were at primary school, oh yes, one day, one of them, I shall not say which, came back and said, my head itches. And then we all had to do the combing and everything. And if your head is beginning to itch, yes, that does not mean that you have head lice. What that means is that you think you might have head lice. And I had head lice, and I was very excited. I got them from my child. And I thought, well, this is fantastic. Someone says, why would I keep it? And the answer is because they're cool. Look how cool that is. And what I like to show people on this head louse is just how well adapted they are to live on human beings. Because, oh, it's not showing it very well, but can you see? I've zoomed in quite a lot. So this head louse is a total of about 1.5 millimeters from its head to its bottom, the other way around. Its bottom is that end, its head is that end, okay? It's a tiny, tiny little insect. And yes, somebody asked, is it dead? It is very dead. This was some years ago now, and it has been kept in alcohol, which stops it from sort of just going moldy or anything. It's kept in, for those of you, if you're interested, it's in vodka. It's all I had. This here, can you see that? That's the claw on the end of its arm. And it's got 6 legs, so there's its head. Okay, then it has 3 legs here, 1, 2, 3, that are sort of tucked under. and 3 legs here, 1, 2, 3. And at the end of each leg, you can only see this one, there is a big hooked claw like that. And the beautiful thing about head louse is you will only find this type of head louse, Pediculus humanis capitis. What that basically tells me, that name tells me that it's the human head louse. That's what the humanis bit means. It's a human head louse. It only will live on humans and only on your head, because only the hair is the right size at that point. Everywhere else, all other animals, your cat can't get them, your guinea pig can't get them, nowhere else on your body, because the hair is of a different size. The head hair is just the right size so that this hooked claw will hook over it, and then there's a little flippy bit here, sort of that hooks onto the claw, that when it hooks onto your hair, it hooks onto it like that. And that's why they're so good at living on us. And basically, if somebody has head lice and you rest your head against their head, then the head lice on that person's head will quickly scurry across to you because they can move quite fast. Now, somebody said, is it a nit? And the answer is no, because technically, it's tucked in at the corner. I'll just move it out. This is a nit. So when I combed my hair, let go, this came out as well. I only had one head louse on me, but because they're all she had laid, I know, don't ask. She had laid some eggs on my hair, and I managed to pull some of those out as well. And this is one of those eggs. This is a nit. That's what we call the eggs of a head louse. And that sticky thing at the bottom, that is actually a bit of my hair. Okay. And what happened is when I combed it, it's glued to your hair so tightly that when I combed it, it broke the hair rather than pulling the head louse off. The glue is stronger than your hair. Somebody asked me, what do they eat? They drink blood. They eat your blood. Okay, that's what makes your head itch. They bite your scalp and then drink a little bit of blood, and then that's what makes them. In fact, if I go back to the female, to the big mummy, if you look here at the back end, that end, right at the end, can you see it's all dark brown? That is blood, my blood, that's dried up, and that was the last meal she had. So I said that was disgusting. So we've seen gross, we've seen disgusting. Let's go back to main camera here, put the lid on that. So yeah, when I saw those, because I'm fascinated by stuff like this, I saw those and I thought, I combed my hair. Obviously, at the time, I was like, oh, head lice, I've got to comb my hair and put the... Anyway, I combed my hair and I had head lice. And I thought, well, that's fantastic, brilliant. Let's put them... And they were alive when I combed them off, obviously. I mean, this was years ago. And I put them in this little pot, put some alcohol on them, which killed it and preserved it forever, so to speak. It's kind of dried out. It's all flattened. And bits of it are starting to fall off because it's a bit old now. But anyway, there you go. So blood-sucking parasites from my head. Gross. Right, we've had spiders and wood lice. I mean, interestingly, the wood louse is not at all related to the head louse. The head louse is a completely different kind of, it's an insect, whereas the wood louse is actually more closely related to crabs and lobsters and prawns than anything else. So something a bit different. Talking of something a bit different, let's look at another specimen. And I want to see if you can guess what this is. Again, you can bung that in the chat as soon as you think you know what it is. First of all, I'm going to get it lined up properly. Oh, I need to do that, and then I need to do that, and then I'm going to focus. So, focus on this, like that. Right, so let me jump to the microscope. So first of all, it's a plant. That much you can immediately see. We've got a plant I'm going to show you. Okay, it's a leaf. The question is not what that it's a leaf, but what plant does it come from? So, okay, I'm going to show you another bit of the plant. I'm going to show you the stem of the plant. and then see if you can guess what it is. Where should we go? We'll go here, and I focus into it. Okay, so now we focused in on a part of it. And it's a hairy stem. And in fact, this plant is incredibly hairy. In fact, most plants are quite hairy. Can you see? It's covered in all those lovely hairs. Nobody's got it yet, though. I'm going to focus in on one particular part of it, though. I've got to move this very gently. Has anyone got it yet? I'm not seeing any. Somebody's got it. I saw the correct answer. There's so many of you, and you're writing answers so quickly. It's kind of, and it's scrolling up like that. But somebody up there said stinging nettle. This is a stinging nettle. The plant is called Urtica dioica. I got it from the other side of the road over there, where there's loads of them growing in the verge. And you can tell it's a stinging nettle because of this sting here. This is one of the stinging nettle's stings. Okay. And you can see the plant is covered in these hairs all over here. This is the hairy part. And plants are often very hairy because the hairs on a plant keep it warm. It's the same reason that we are hairy, or your dog is hairy, or a bear is hairy. It keeps it warm and stops it getting too cold in winter and freezing. But this plant has specialized hairs as well. And that is one of them right there. It's quite a good one. That is one of the stinging cells. Now, you'll notice, by the way, this is quite a good example. Everything I show you, I'm not showing you pictures of things. Well, obviously, I'm showing you pictures because, well, you're looking at a television screen, presumably. So those are pictures. But I'm not showing you pictures I took kind of 2 days ago or something. This is all live microscopy. These are all specimens under the microscope for real. And that's why it takes me sometimes a while to find the specimen. And also, I have to focus because, you might have seen with a camera, when you use your iPhone camera, you have to focus on it. You tap and it focuses, or your phone camera, okay, or parent's phone camera, or whatever camera. You focus so that it's sharp, and the stuff that's out of focus is all fuzzy. So at the moment, I'm focused at the top of the stem, and you can see, so I'm focused here. All these hairs are in focus, and this hair is out of focus. And if I now change the focus, there's a big wheel at the side here I'm turning. Now the stinging cell is in focus. And I'll just get it so that we can see. And now you can see why stinging nettles sting. Right, I'll go back. Sorry, I'm just jumping back to the, let's have a look at the chat quickly flying past. Yeah, so that is a stinging nettle sting, and it is fantastically sharp. It is about 1 millimeter long total from bottom to top. Now, if I show you, I've got here a little pointy stick, okay, which I use. You can't really see it. If I put this, jump to this camera quickly, you can see I've got a needle here mounted on the end of a little metal pole, and it's quite useful for when I'm sort of using things. I can sort of poke them apart, and you can see that's sharp. Okay, that if I just jab that, where are we? If I just jab that into my finger, it will go into my finger. It's a sharp needle. Okay, let me show you how sharp that needle is when I put it next to the sting that's now on the screen. This is a bit tricksy because so there's the tip of the needle now, and I'm a bit shaky. And can you see how blunt it is when you look at it under the microscope? That's a really sharp needle, a metal needle. Ooh, and ooh. So this needle is really sharp, but compared to the stinging nettle, it's blunt, 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 blunt. It is the most hopelessly blunt thing. These things are ferociously sharp. And if you brush against them, what happens is that needle will pierce your skin. It goes straight into your skin, okay? Straight in. In fact, there's another one just at the bottom. Can you see? There's another one sort of sticking up there. And there's another one there on the left-hand side that I'm just focused on now. Okay, so they're all over it. And if you brush against it, it sticks straight into you. And then what happens is at the bottom of the stinging nettle sting, can you see there? right at the bottom, there's a little sort of lumpy bit. And inside there, there's a little blob of liquid. And that liquid is then squeezed by you as you push against it. And it injects itself into you, because that needle below me here is not just a sharp spike, it's hollow. It's a needle with a hollow bit that goes up, and it will inject the liquid into you. And once that liquid has got into you, there's two liquids. There's an acid called formic acid, and there's another type of, there's actually something called histamine in there, which is what makes people who have hay fever suffer from hay fever. And those two things cause the little swelling. You know, you get a little bump, it's called a nettle rash, and it's really itchy and painful. That's caused by those liquids that are injected into you. It's quite vicious, really. And you might be thinking, yes, indeed, somebody says there, Gemma and Patrick says, don't ants have formic acid? And yes, it's the same stuff. Okay, yes, ants can spray formic acid. Some ants, not all ants, but just a few can. So that's what happens when you get stung, which is cool when you look at it like that. So let's zoom right out. Stinging nettles are actually fantastic. I could talk about stinging nettles for quite a long time. And the other thing about stinging nettles is they're usually covered in insects and aphids and things like that. I could do a whole talk just on what I find on a stinging nettle. They're fantastic plants. A little bit vicious. You might ask yourself, why, if they're so vicious, why are they so vicious? Why are they so horrible? And the answer is quite simple, actually. The reason why stinging nettles are so horrible is because they don't want to be eaten. The sting of a stinging nettle is there entirely to protect it from being eaten. Right, let's move on to something else. Let's move on to something really small. We've looked at big things. Let's look at some really tiny stuff. I've got here, where is it? What have I done with it? I've lost it. Oh, it's behind my cup of coffee. Here it is. I've got here a little pot. I've got a pond out front, just a tiny little pond. But even so, we've had it, we dug it up just to grow wildlife, basically, just for wildlife. So in that pot, we've got loads of insects and things. So I thought I'd take a look and see what there was. So let me show you what there is to see inside a pot of water from my... Now what I'm going to do... So what you've got here, it's a complicated looking mess. And what we've got is loads of pondweed. There's some duckweed, which is the sort of the flat sort of leaf shaped things. And there's a lot of little filaments, little thin skinny bits. But if you just look for a second, you can begin to see that there's loads of stuff in here. I'm not going to do anything. I'm just going to, can you see just here? There's a little tiny creepy crawly. Okay. That is actually a mayfly larvae. I can tell that. But if I focus down to the bottom, look, there's a little wormy thing there. You see that? Little gross wormy kind of doing its thing. But there's also a lot of much, much smaller stuff. Let me see if I can show you some of the small stuff. There's the mayfly larvae. You see that? There it is. And I've got the brightness up a little bit. Should we go right? Let's turn the top light off. One of the secrets of microscopy is that you need to adjust, you need to mess around with how you illuminate things. That's actually half the problem. And if you've ever got a microscope at home, actually getting the illumination, how you shine light on it right, is the half the problem. But there's other stuff in here too. Look at that, just zipping around. Weird. Do you see that? There's all sorts of crazy things moving around in there. There's one there. There's a little thing there that's chewing on a piece of. Look, there's a little tiny white thing zipping around. There's a little wormy, another worm. What else? There's something weird there. And if I focus. And if you just pause and watch that image for a second, you'll see that there's loads of stuff moving. There's something whipped through. the pond water is absolutely living with stuff. There is so much life in that pond water. And that if I keep looking at smaller and smaller stuff, you will see that there are still smaller and smaller and smaller and smaller creatures. In fact, every single tiny little speck of white light that you see in here, if I zoom right in, can you see? There's a few things I can show you here. This thing here, for example, this thing is a tiny little flea, water flea, called an ostracod. And can you see there are lots, if I have to stop moving, can you see there are lots of tiny little green specks that are moving around? Those are single-celled algae, like plants that you would find on the seashore, like seaweed, but they're just single cells and they have little wiggly tails which moves them around. There is so much stuff in here, but I want to show you one particular thing. I want to show you some creatures here, which I have to zoom out for. And these creatures are particularly cool. These creatures are called Hydra. And I found these, you find these inside in the pond, and these are, okay, these are Hydra, these are related to jellyfish. And can you see this creature here? It's sort of growing out and it's got these tentacles at the end. There it is. Can you see all the tentacles at the end? That it moves them out and it's growing itself. It's getting bigger and bigger and it's hunting its prey. And these things are fantastic creatures. They are some of the most bizarre things you're likely to find anywhere in your garden because they are essentially immortal. They do not age. They just keep living and keep living and keep living. And the other thing is, if you cut one in half, if I were to slice this thing in half, which would be cruel, but there's another one there. If I were to slice it in half, two would grow. Now, sometimes people say that worms, if you cut worms in half, they will grow into two worms. This is not true. If you cut a worm in half, it dies. And that's the end of it. But these things, if you cut them in half, you will get two of them. The top will grow, the bottom, if you cut them sort of that way, so it's a stalk with the tentacles at the top. If you cut it in half, the top bit will grow a bottom and the bottom bit will grow a top, and you end up with two of them. If you cut it into three, the top bit grows a bottom, the bottom bit grows a top, and the middle bit grows a top and a bottom. That is super, super unusual in biology. And you can see how it's sort of stretching out. And then if I give it a little gentle poke, which is a bit tricksy. Where are you? It kind of sucks itself back in, and it's kind of like this little blob of jelly, living jelly, and they're tiny. And when they're stretched right out, they're about 1 millimeter long total. So that's a cool thing that's living in your garden. Right, okay. Let's put the lid on those, and I'm going to slide them over there out of the way, because now I'm going to have a quick slurp of coffee. Somebody says, how big is it? About 1 millimeter when it's stretched out. When it's all scrunched in, it's, you know, like 1/4 of a millimeter top. It's this tiny, tiny little gobbet of sort of jelly, so to speak. Okay. Right, what should we do next? Let's see. Where am I going next? Right, we've at this point, we've looked at lots of things with this microscope, but I haven't used this one. This microscope is good for looking at things much smaller and much closer up. This gives me what's known as more magnification, so I can make things much, much bigger. So let's look at something else. Let's look at a sample from me. Let's look at a sample of blood. Now, normally I would get one of you to donate the blood, but that would take a long time. So what we're going to do is I'm going to donate blood for you, and I'm going to use this thing here. Okay, this is called an Accu check fast click, and this is a device for that people who have diabetes use when they have to take a test. And all it does is it's got a tiny little, can you see there's a hole at the end there? It's got a needle inside, and when I press the spring-loaded button here, the needle will pop out and go into my finger, and hopefully I can get a little bit of blood. So, okay, here we go. Let's do this for you. And yes, I am going to bleed for you. Here we go. A nice warm day. Where's the camera? There's the camera. A little bit of blood. Hey, blood. And then what I've got here is a glass slide. Somebody's saying there, is the Hydra closely related to the immortal jellyfish? Yes, they are the same type of thing, but they're both hydrozoans. What's the biggest thing you've shown us today? Probably the spider. Well, I'm quite big, but I'm only showing you a very tiny bit of me. So what I'm going to do is I've got a glass slide here. I'm going to put the blood at the bottom of the glass slide here, like that. Okay. That's a little bit of blood, and then I shall try and stop myself from bleeding. And then I've got a second glass slide here, and I'm going to use that to smear the blood out. Here we go. So to do that, I go, and then I go, whoop, like that. Like that. And that has smeared the blood out. You can just about see the blood. Okay, and now I'm just going to wait until that's dried. Is that drying? That is drying out nicely. Yeah. And you can see it's just about visible. You can see a sort of a pinkiness there, can't you? That's just about there. So now I'm going to pop this under this microscope here. And then this microscope, the way this microscope works is because it's a bit more complicated, it's a much more complicated microscope. I can't show you, I have to find the image first and then I show you the image. There's a lever here I turn over. So I'm just going to look. So first of all, I have found blood. I have definitely bled for you. And, you know, it's not often that you get a performer to bleed for you, but there you go. So I do that. Are you ready to see some blood? Hopefully you are. Somebody says, I want to be a surgeon. Top job. Well done. Here you go. Here's what blood looks like. Oh, wrong camera. We're still on this one. All I have to do, though, is go, thunk, and there you go. That's what my blood looks like under the microscope. The thing is, you're looking at that and you're thinking, well, okay, but it doesn't really look like blood. You can tell this is for real because look, if I just bang the table, the whole thing wobbles because this is really, really small. Each one of these blood cells, because that's what they are, because you and I are made up of individual cells. There's about 35 trillion cells in each of you. And these are just a few blood cells. And each one of these cells is 8 millionths of a meter across. Okay, that's quite difficult to imagine. So you know what a millimeter is? You kind of know what that is. It's like that big. It's tiny, tiny, tiny. And a millimeter is 1,000th of a meter. You take a meter, you go chop, 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 chop into 1,000 and you get a millimeter. If you take 1 millimeter and you go chop, 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 chop into 1,000 parts, you get what's known as a micrometer. And these blood cells, these red blood cells, are 8 micrometers apart. And you're thinking, well, hang on a minute, Marty. You say they're red blood cells, but they're not red. Yes, they're not very red. They are ever so slightly red. If I look down here, the camera's not quite as good as your eyes at seeing things. And in fact, I can see there's an ever so slight redness to them, but only slight. So what I need to do is I need to color them in. And we're going to do that quickly because I'm starting to run out of time because I've been answering so many questions. And the way I'm going to do that is I'm going to use some special chemicals here. And these chemicals, pull back a little bit, just adjust my camera so you can actually see what I'm doing. You can see my tummy in the background. I've got these 3 chemicals here, and I'm going to take my slide and I'm going to dunk it into the chemicals one after the other, and then wash it off afterwards. So, are you ready? Okay, and this will color them in. These are like paints for cells. Okay, the first one goes in here, and we do it to the count of 5. 1, 2, 3, 4, 5. Is that? I'm running out of this chemical. That's good. That one's done. And I'll just dry that off and move that out of the way because I do not want to spill these on me. The next one, this sort of pinky one called eosin. 1, 2, 3, 4, 5. Get rid of the excess. And the last one, dark blue chemical. Toluidine blue. 1, 2, 3, 4, 5. And do that. And then I need to wash off the excess like this. Get rid of all the excess colours, and you can see them all kind of making the paper messy there. And normally when you do this, if anybody does this in a laboratory, sort of proper science, it would take you a month or something. It would take you, you know, like half an hour to do this for reals. Okay, and then I need to dry that off and dry this bit here and that bit there. And then I'm going to just use a huff of air, a blow. I'm going to blow, but I'm going to go over here so I don't blow straight into the microphone. Right, and that will help that dry out. And now what I need to do, get rid of that, is dry this out as quickly as possible. Because now you can see it's been coloured, but these colours are specific. They actually colour different parts of the cell. Let's see, is that dry? I can't tell. Yes, it's dry. Right, let's bung that back under. I'm going to have a look, see if I can find what I need to see. Yep, good, 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 good. Right, and now I'm actually looking for something very special. I'm looking for something specific. There it is. That'll do. And I'm going to zoom in on this and show you what's to be seen. Okay, that's kind of cool, actually. Let's just do that. So now, turn that knob, go to the microscope. Then pow, now we have the blood cells again. And this time I've used this pink chemical here, right? This pink chemical has colored the insides of the cells a kind of a pinky purpley color, okay? And it does that to the inside of all cells. And now you can see, and they start to look a bit more like they would in a sort of CSI program, yeah? But this chemical, the blue chemical, well, it doesn't appear to have colored much. And that's because it colors, this chemical colors cell nucleuses. And that's a type, you've got organs, you've got a brain and a heart. Cells have like a brain as well, or at least they have what's known as a cell nucleus. And if I move down to here, you can see there is a cell here that has a cell nucleus. It's this one here. Can you see that? It's a big round cell and it's called a neutrophil. It's not a red blood cell. You cannot see this cell unless you stain it. It is essentially a see-through cell, okay? Even more so than the red blood cells. And you don't see them at all. You only see it when you stain it. And that neutrophil is a white blood cells, okay? And the white blood cell, and in the middle of it is the cell nucleus, where the DNA that makes me is. And the DNA is in sort of little gobbets, okay, which is why I know it's a neutrophil. There are different types of white blood cells. There are about 20 different types of white blood cells. And this is the easiest and most common. There's about 70% of these. And these are basically vacuum cleaners, and they go around your body, hoovering up cell things that aren't supposed to be in your body. So right now, okay, we're all staying indoors. I'm here in my home, you're in your home because of a virus, because of the coronavirus and the disease it causes, COVID-19, okay? And your white blood cells are the things that will protect you from that disease and any disease. Now, these ones are specifically there to tackle bacteria. So they don't actually necessarily do much against a virus. Against a virus, we've got a moment, I can find a different white blood cell, which I have here. You've got a couple of white blood cells there. You've actually got two. The red blood cells have kind of gone a bit weird. You've got one here and one here. And these are lymphocytes. These are a different type of white blood cells. And these are the type that will help you combat and defeat a virus. So if you're unfortunate enough to be exposed to coronavirus, it's these cells that will help keep you safe and keep you well and healthy. So without those, we'd be in dire trouble. Okay, I've already run probably over. I was supposed to do 45 minutes, and I've now gone on almost on to 50 minutes, and they have something else coming up at 10:30. So what I'm going to do is I'm going to come to this, and I'm going to put my glasses on so that I can actually see the questions. If you've got any specific questions you want to ask me about anything, please put them in here, and I will try and answer them. But other than that, if you want more microscopy, I suggest you go to my YouTube channel here, which where you will find all sorts of microscopy. And basically, because throughout the lockdown, I have been live streaming. I have been live streaming microscopy from literally from here. I started out 3 times a week, and now I'm only doing it once a week because I'm getting busy with other things. Somebody asks, how do you get more white blood cells? Your white blood cells only live for a few days, and then they're constantly being made, constantly being made. If you get too many white blood cells, it's actually you can get a cancer of white blood cells. Can I put up the YouTube channel again? It's very simple. It's my name. How do I get the colors? The colors, well, they come from those chemicals I added. Those chemicals are essentially paint, but they're not paint that just goes everywhere. It's kind of like coloring by numbers. The paint goes to individual things. How much was the blood magnified? The blood is magnified. Well, it's quite difficult to tell exactly how much the blood is magnified. I was just looking. It's about 400 times. Okay, but the important thing to know is that each of those red blobs, the red blood cells, are 8 millionths of a meter across, 8 micrometers across. Cool. If you want to follow me on Twitter, that's my Twitter. I tweet about stuff. If that's actually the best place to find, if I'm live streaming, I live stream on Twitter and on YouTube, as I say, every Friday at 12:30. Okay. So I think that is the DNA in your blood. Actually, the DNA is only in the. It's not actually in the red blood cells, these blood cells, because they don't have a cell nucleus. Red blood cells don't have a cell. They're the only type of cell in your body that does not have a cell nucleus. So it's in the white blood cells, but not in. Is the scalp a microhabitat? Yes, it is. There's bacteria, there's fungi, there's little animals, there's mites, there's the head lice, all sorts of things. Why are blood donut shaped? The blood cells, you'll see, actually this shows quite nicely here, are sort of shaped like little donuts. They're donut shapes because they don't have a cell nucleus. The cell nucleus has been pooped out, and the cell, which starts out like a sphere, goes and collapses. And the reason it does that is so that the blood cell becomes more flexible and easier, and then it can get into the very, very, very tiny blood vessels in the tips of your fingers. What happens to your blood cells when you take medicines or drugs or alcohol? Depends what you take. There are some blood cells, some things that don't affect you at all. And in fact, mostly things don't affect you, but there are some things that will obviously affect you. Some drugs will affect your immune system quite a lot and will either suppress it, so make it work less well, or make it work better. And if you are taking drugs that suppress your immune system, if you have older people with cancer or some diabetes and stuff like that, sometimes you have to take them. That's why they have to be in shelter. That's why they're sheltering at the moment from the virus, because their immune system doesn't work so well. They say there are so many cells in yogurt. Is it true? Yes, yogurt is full of bacteria. Bacteria, much, much smaller than this, harder to see. Where is your DNA? The DNA specifically is inside, boom, the dark blue bit here and the dark blue bit here. I mean, there's other stuff in there, but that is where some of my DNA is. Okay, what else? Thank you very much. Very cool. Cool. Right, I should probably draw a close to this so they can get the next person on. Angela, is that okay? Have I got time to do any more questions?
I think if you've got a minute, if you want to do any last questions that come in, Marty.
Any last questions that come in once that's happening, I'm just going to take another. I'll put up my YouTube channel again. Hopefully they'll put this in the bottom. Come and join me again for something. What are the largest germs you could look at? Well, germs, bacteria, somebody's asking, are super, super small. They are We are now talking less than 1/1,000,000th of a meter, so 1 micrometer, and you'd be hard pushed to see bacteria with a school microscope at all. What about a cactus needle? Don't know. Never looked at a cactus needle. I'm going to do that for you. If I will try and look at some cactus, but I've never looked at cactus under a microscope, so I think I might do that. My son has lots of cacti. I shall look at some of those. Good question, Mark. I'll look at those. Why do stinging nettles not hurt cats and dogs? They do. It's just the cats and dogs are covered in hair, and generally speaking, it won't get through the hair. But if it touches them on the lip or something like that, it will hurt just as much as it hurts you. What's the comparison between a bacteria and a virus? Oh, complicated. Viruses are technically not alive. They are only DNA and a little bit of protein. They're not living, but they reproduce. It's quite complicated, and they are much, much smaller. Right, I don't have time for any more. Thanks very much. Get in touch with me on Twitter if you want to send me any more questions. Thank you very much. My name's Marty Jopson. You've been a fantastic audience. Thanks for all the questions.
Wonderful. Thanks all for tuning in. Thank you to the wonderful Marty Jopson. Virtual round of applause. And don't forget, head back to the website to look at all of the other options that are available to you that are streaming out today between now and 5:30. And again, come back to the website and check. All these recordings will be available for you to use either in your classrooms or at homes with your family. Thanks very much. Big clap, round of applause.